Data structure using C++, VTU question paper discussion, session 1. Today we will discuss December 2018, January 2019 question paper with solutions. First question which was asked was explain the working of recursion and template function with examples. So this was asked for 8 marks. So what you are supposed to write and what not. So you can just observe the answer solution for this. So what first we will brief about what is template function. So literally template function is the one which will not bother what arguments you pass onto this function. It will give you the correct result. So that's for making your function generic. You can always use this template function. So the prototype is defined here and one example is given. So what basically how to define a template function, then how to instantiate it in the main program is also addressed. So this is your example template function. T will be the variable which could belong to any data type. In the main program we will be using as the function name. Template function is invoked using the name. ABC is the name of the function, and we define a data type here within angular braces, which will be the variable supplied, which goes to the function class T, and this will come to know that T is integer now, and the argument. So 3 arguments it will take. So only one extra overhead what you have in template function while instantiating is the data type. You have to supply this data type to the function so that it will understand what is the data type provided by the user. Followed by that, the example, explanation for recursion. Recursion is a function which calls another function. So in recursion you have 2 types. One is direct recursion and one more is indirect recursion. So in direct recursion one function calls another, and in indirect recursion one calls another function, the second function may call third function, and finally the last function will again call back the first function. So it will be kind of a loop based. So that's your indirect recursion. So whenever you define a function, there will be 2 components present in your recursion function. One is a base component and one more is your recursive component. Base component has definite expression, and recursive component is not definite. It has to be repeated. So you will notice what is this. So here you have defined f of n is equal to 1. So this is actually an equation which we will model it for finding a recursion of for finding the factorial of a given number using recursion. So this says that if n is less than or equal to 1, then 1. So you have this 1 value which you call it as a base component. Based on this condition your program should terminate. So otherwise it will always call the function again and again. So here if f of n is a function, so you can figure out n into f of n minus 1 is actually the returned value which will be returned back, which means it is going to call back the function again and again. So that is for the condition n greater than 1. So if n is less than or equal to 1, in that case the function will come out of the loop, and the function no more calls it again. So you can terminate the function, and signal flow or control flow goes back to the main program, and it will start executing the main program henceforth. So this is your base component, and this is your recursive component. Recursive component means recursive in the sense call it again and again, same function. Okay, so this is what is expected for your question number 1A. So both have to explain both what template function is, what recursion is, and provide one example each. So this was an example given here for template function, and this was an example given for addressing your recursion. Second question. So this was asked for 8 marks, first question. So all questions are asked for 8 marks here. So you can expect the same question to be asked for 10 marks in your case. So second question, write the ADT of a linear list. First question, develop C++ template class for linear list in array representation. So what you are supposed to write, first write down the ADT. What is ADT? Abstract data type class, or abstract data type doesn't have any programming language, syntax or semantics. It's in general kind of a algorithm, doesn't depend on any programming language. So you write what components you require for developing this linear list. For example, if it's a linear list, then some of the methods which we expect a linear list to have are empty, size, get, index of, erase, insert, and here the elements present in a linear list are the ordered finite collection of 0 or more elements. So this could have no element, this could have more number of elements. So it is simply a collection of ordered elements. Okay, so these are some of the methods which we expect expect the data type like linear list to have. Similar to array it is. Okay, so this doesn't have to do anything with C++ programming language. Whereas the next question which was asked is develop a C++ template class. So here you are supposed to write a C++ program. So it would be an abstract class you can write the abstract class or template class, okay, for a linear list, which means just replace wherever you have empty, write void virtual void, use the keyword virtual void and set that method to 0. That would convert this abstract data type into abstract C++ class. So you can figure out the same linear list has been converted into ADT, is converted into abstract ADT, C++ ADT, by replacing all the methods with virtual, and this is having one extra method, linear list destructor function, for deleting your class objects when the program terminates. Along with that you have all other methods. So again 8 marks. Expect 4 marks for this explanation. If required you can explain this, and 4 marks for this. Altogether 8 marks. The next question is what is dynamic memory allocation? Describe C++ mechanism of dynamic memory allocation for 1D and 2D arrays. So what you are supposed to write, what is dynamic memory allocation? So what is dynamic memory allocation? It is actually a concept of creating a memory during runtime. That is one main difference between dynamic memory allocation and static memory allocation. In static memory allocation, as soon as you compile the program, the memory will be allocated for a particular variable if it's been used. Whereas in dynamic memory allocation, you will be creating a memory with the help of pointers. So it will be created at the time of runtime. So it will not be created during compilation time. So note this difference. Okay, and so to create a memory we use a function named or operator named new, and to deallocate the memory which we have created using new operator, we will be using delete operator. So new and delete operators we will use for allocating and deallocating a memory, and this new and delete has to be explicitly written by the programmer, and the programmer is going to create or destroy the memories. So this is one more thing which needs to be remembered. So I've given one simple example for creating a simple object using dynamic memory allocation concept, and one more example wherein we create a set of, or you call it as a set of objects, or you call it as set, okay, with more elements. That's your for creating an array. Okay, and for deleting one object, we just delete the pointer which is used for creating the memory, and if it's array of if it's an array which we need to destroy, then we will be using a square bracket indicating that the pointer used for creating an array has to be destroyed. So we just define this commands, and this is one example for making a 1D array, and this is for deleting an array. So since in the question it is asked for 1D array and 2D array memory dynamic memory allocation, you are supposed to explain, so you can include this program. So what does this do? This takes an argument x and it takes an argument size. So based on the size provided by the user and also the variable given by the user, it is going to create a memory for the variable x. So pass the variable directly, then this is going to create a object belonging to any data type. So it will create object, for example, if t is floating point number, then it will create a floating point array with this many number of elements, size number of elements. So in delete array, 1D array, we just use delete square bracket x. So this takes only one argument, x. Size isn't required. So this is actually the pointer for creating the array, and it has to be deleted. So use delete square bracket x. Now suppose if you're talking with respect to two-dimensional array, so here you can see that this is your x variable. So here we will be using double pointers, and this is the data type reserved t, template class it is, and this the number of rows, number of columns. So first what we need to do is we need to create a row pointers. So it is created with the help of x is equal to new t star number of rows. So this means create an array of row pointers, and each pointer, so say once you define this, so suppose if number of rows is equal to 3, then you get 3 row pointers. So x at 0, x at 1 and x at 2 all are pointers. So x at 0 star, x at 1 star and x at 2 star. So each of these pointers, through each of these pointers you have to create an array with the dimension is equal to number of columns. So that is created with the help of this command. So this make 2D array, job is to create a two-dimensional array here. Okay, so this is the way to create. And the next example is to destroy, deallocate a two-dimensional array. So we will be using delete. This is for destroying the column, the row pointer, the memory allocated with the help of row pointers. To delete that array, we use delete of x of I. So first all the arrays or all the memory created with the help of pointers, delete that, then finally come out of the loop and delete the row pointers. So this is how you delete two-dimensional array created with the help of make 2D array, and for destroying you will be using delete 2D array. The next question is develop C++ template class chain node and chain that implements linear list in linked representation, define constructor and destructor member functions. So again, this is asked for 8 marks. All questions are asked for 8 marks. So here first you define the node, chain node. So in the nodes you might have taken template class T, and have defined T element and chain node T. T is for data type. T could be any data type, and this was defined as next. But we had 3 different modes of configuration. So I don't know in the nodes if it's 1, you can include this again. So this node, which we call it as a chain node, is singly linked list concept. So here one possibility is your node can take no argument. That's this. So it doesn't do anything if you don't pass any argument. Suppose if you provide one argument to this chain node, then that element with the help of this pointer, this is the implicit, you call this as the implicit this pointer, which will be associated with every member function belonging to the class. And so since you have 3 member functions here, constructors basically, they are also a member function. So this constructor will also have this pointer. So using this pointer you can grab this element passed by the user to the class. Okay, so this element is an argument passed applied by the user, and it will go to the class with the help of this pointer. So this gets element information, whereas this gets the element information as well as the next node where it has to point that information. Okay, so this is having 2 arguments. So this requires this of next to be filled with the help of the statement this next is equal to next. So this is the configuration for your chain node. Chain node structure looks like this. So I repeat, this is having 2 components, element and next. So these are 3 different modes of configuration. And this is your destructor chain node destructor function. So here it is asked, supposed to uh, define constructor member function and destructor member function. Okay, so destructor constructor member functions are this is the structure definition. In destructor function we'll discuss. Constructor function was already discussed, so you can just go through it. Here in the destructor function, you have chain function. So while first node not equal to null, what you have to do is you have to check whether the first node did we reach the first node. So that's what we are looking for here. If you have reached the first node, then stop the iteration. If that is not null, then you have to continue and you have to keep on deleting the node. So here first we create one node, name it as next node, and it will point to the next of first node. So first node, what is first node? First node will be the starting node. You can call it as a starting node. Okay, then next node we will make it point to the first node first, and that first node is deleted here. Okay, after that, once the first node is deleted, then the next iteration we make next node as the first node. Okay, so we destroy the first node, then next iteration next node is made first node. This is how we destroy all the nodes present in your chain function. So this is the job of the destructor to do. So constructor has to create a node, and for creating a node there is a method. You can just go through it. By mistake I just forgot to address that here. Okay, third question, develop a C++ class that maps diagonal matrix of order n by n into a single dimensional array. Write member functions for store and retrieve operation. So first you have to write a function C++ template class. This is your C++ template class, and it is the job of this class is to take n by n element. So this is the n is n by n element, so that's the dimension which you provide here. Suppose if we expect if it's a 3 by 3 matrix, then altogether it will be having 9 elements. 9 elements, and so the n is this n by n, you take it as the n. Okay, so if n by n, if it's a 3 by 3 matrix, then 3 will be the value which will be considered, because we know that the diagonal matrix, if it's 3 by 3 diagonal matrix, only the elements which we are interested with happens to be the diagonal elements, and whose size will be equal to n if it's a n by n. So we have to transform this n by n matrix into an array with the dimension n. So possibly this is n, which is your n by n value itself, the n value, and so this one is written to ensure that the matrix size matches or it is proper. Otherwise you'll get illegal parameter value. Suppose if you enter a value lower than 0, if it's, or even if it's equal to 0. So if not, then n is equal to the n, then element new t of n. So this is the way to create memory or allocate a memory using dynamic memory allocation concept. So element is a pointer, and using new instruction, this is for the data type t, we create this much room. So that's what is actually the mapping from n by n matrix to one dimensional array. Then the store and retrieve functions. So store and retrieve functions are nothing but store is nothing but set method, retrieve is get method. So you can just observe set method and get method of diagonal matrix. So here we check whether the user has entered the proper index. If he has provided the proper index, then it will jump to this. So it will check the condition if I is equal to j, which means this is a diagonal element. For diagonal matrix, the condition is you need to look for the value of I and j, and if it matches, then that's your diagonal element which you are. So in that case, the new value whatever you provide, so this is to replace the diagonal elements with the value which you provide. So say that 1 comma 1 position, if I is equal to 1 and j is equal to 1 comma 1 position, I want 2 to be replaced. previously there you might have 1 there, so 2 will be replaced at the position 1 1. So that is obtained with the help of here this instruction. So element of 0, we write it as new value. So element of 0 position, the first element will become 2 now. Okay, and this is to check if new value not equal to value, non-diagonal elements must be 0. Suppose if you try to add a value when I is not equal to j, then it will provide you a message. It will pass an exceptional case saying that that's not the correct possible way, and this is non-diagonal elements. It should be forced to be made 0. It cannot be non-zero. It should be 0. Okay, now this is 3b. Write ADT specification for stack. Develop a C++ class to implement stack in linked list, linked representation. So here you are supposed to ADT or specification for stack you have to write. So I have not written it. ADT of stack, you have top method, you have push method, pop method, and the elements which are elements, a set of elements. So that's your ADT. So ADT doesn't have to do anything with the C++ program, so it is simple. So it's already defined in addressed in PPT. You can refer that. A template class to implement stack. So this is your template class with methods, which the methods which you are supposed to write address properly are push and pop functions. So push function is defined and pop function is defined. So push function, you have to insert an element. So insertion and deletion both happens at the same end in case of stack. Okay, for deleting, again top of the stack will be the pointer which you will be using, or you call it as a stack top. Stack top will be a pointer. So what you do basically, if it's a push operation, stack through the stack top, the element is actually the value which you want to push. Stack top will be set to new chain node. You create a node, then you place the element, and it has to go to the stack point. It has to reach the stack point. Okay, so this stack point would be rewritten. Earlier the stack point position would be, this will be the top of the stack. Now this becomes the top of the stack. Okay, so that's how it is done here. So this top of stack gets connected, and also the stack size will be grown. Okay, so this is your push method. Similarly, the pop method is here. So you check whether the stack size is equal to 0. If it's 0, then it is empty stack, or else again create next node and make it point to the stack top of next. Make it point to the second node, not the first node. First node will always be stack top. Okay, in case of stacks, so first node will be stack top. So you ensure that the pointer is pointing to the second node, next node. Then you delete the first node, that is the stack top. Then you ensure that stack top for the next iteration becomes next node. Then you can delete stack size minus minus, so one element you destroy. So this is your pop function and push function. So remember, always in push function you will be using new operator. Pop function you will be using delete operator. Okay, the next question, fourth, what is sparse matrix? Explain row major mapping of sparse matrix to linear list. Develop a C++ template class for sparse matrix. So here you are supposed to address what a sparse matrix is. Sparse matrix is a matrix wherein you have more number of elements as 0, and the way to represent sparse matrix, you can use this representation, linear list representation. In linear list representation you use 3 identifiers, row, column and value. And if you consider this as your sparse matrix, so many of the elements are 0 and few elements are non-zero. Just figure out the non-zero element, its row position and column position. So 2 is your non-zero element. In the first row you have 2 non-zero elements, 2 and 1. So the position of the first non-zero element is row 1 and column number 4. So we write the element value as 2. Value will give you the value for this sparse matrix, non-zero element value, and its position is addressed by the identifiers row and column. So 1 and 4 talks about the position for your value in the matrix, in the linear representation form. So when you observe this method, this is not that best or feasible method, because you require more memory locations here. So here you will have just how many elements you have: 4, 5, 6, 7, 8 elements are there. But when you observe 9 elements are there, sorry, when you observe the total number of memory consumed, it is 9 times 3, because for position and column you require those many number of spaces to be created. So it is not that great method, but still can be used. Okay. Then the sparse matrix for yeah, this is your sparse matrix header, which has methods transpose add, and they have asked you just to address the sparse matrix header, rows and columns and constructors. So this is not that important, since it is asked no, template class. Yeah, template class, in the sense this is fair enough. If you address, you do not have to write the transpose and add methods here. Just indicate how many methods this sparse matrix utilizes. Some of the methods sparse matrix are transpose and add. Then have write and explain C++ program that inputs a string and outputs the pair of matched parentheses. So parenthesis matching program is given, so you have to address how this program works, and this is already addressed. So you just check for opening braces, curly and closing braces, its position you observe, and positions are passed on to the stack, and you just always you will print for the left braces what is its equivalent right braces. The position will be addressed here, and you can figure out if there are more number of left braces and less number or lacking right braces, and the parenthesis is not matched. So parenthesis unmatching happens. So you can just figure out for which left braces you don't have its right parenthesis counterpart, that you can identify using this program. Program was also explained. So here so this was asked for 8 marks. So to some extent you have to explain. Don't just write the program. Explain the theory. Take one simple example. What will be the output for that particular input given? You have to address, because it's explained here clearly. Take one simple example. Take a string with curly braces, not curly braces, you take a parenthesis, and just talk about what will be the outcome. You can take 3 examples or 2 examples, and you can address. Then you just write this program for that particular example. Just try to explain. Fifth question, develop a C++ template class to implement circular queue in array representation. So here you have 2 methods, push and pop methods for circular array. Array representation has to be addressed. So in queue, one main difference between queue and stack, we know it's something like in queue, insertion happens at rear end and deletion happens at the front end. Okay, so you have queue back and queue front. Queue back is equal to rear, and queue front is also equal to front. Okay. So here what we do is, for the push function, we check whether you have enough space in the queue. If there is no enough space, then you have to double the array. Doubling the array is not addressed here, so you have change 1D array. That program has to be called. And queue back, if not, what you do is insertion happens at the queue back end or at the rear end. So rear will be incremented. So this increment is circular queue. So you will be using circular operator or modulo operator. So suppose if it goes to the end of the queue, for the next iteration, if there is a space at the queue front, it will reach that position finally. So it increments in circular fashion, this method. Okay, so even for pop, you will be using modulo operator, because of which we call this as circular queue. And circular queue is very much effective than linear queue, because more number of memory allocations you can um, uh, consume. Okay, it utilizes almost all the memories which is created for a particular circular queue, whereas linear queue there are some exceptions. And this is your pop method. So here insertion, this is for delete you will be using q front pointer. So this pointer is incremented, q front will be incremented, and you will be the element which sits at q front will be destroyed using the destructor function. So this is your 5a. Explain dictionary, data structure, illustrate the example, the process of search in a sorted chain with the example, define member function sorted chain to perform search operation. So here in this case, this is to address sorted chain. So what you have to do is you have to explain each element present in the dictionary will be having the key and values. So how to search, how to perform search. So here one assumption what we make is we say that all the keys present in this list happens to be sorted already, so due to which we can use this program. So the name of this program is sorted chain, because all nodes are having key elements and those key elements are ordered, they are already sorted out. Okay, so here to figure out whether the key matches, the key is present in the dictionary, you will compare the key with the element dot first. So if the element dot first is equal to the key, then you say that that's your particular node where you have a key and you return that. So this is the condition where you identify that there is an element present in your sorted chain program. Okay, time being we will stop. The second revision class we will discuss in a while.